Hey guys, so today we're going to see the word break problem. It is problem number 139 in LeetCode. As you can see, this is a medium problem. This is a problem which is asked very frequently in FarmG companies, especially Amazon. Okay, so given a non-empty string S in a dictionary word containing a list of non-empty words, determine if S can be segmented into space-separated sequence of one or more dictionary words. So if you consider the notes section, it says that the same word in the dictionary may be reused multiple times in the segmentation, and we assume the dictionary does not contain duplicate words. So given an example, one, so if you see S is equal to LeetCode and word dictionary consists of leaded code, and this is going to be true because LeetCode can be segmented into lead and code. Okay, and if you see the example 2, apple, pen, apple, it consists of apple, pen, and apple, basically apple getting reused. So it is true because all three words are present in the dictionary. And let's look at example 3. So cats and OG, right? It's not cats and dog, it is cats and OG. So cats is present and is of course present, but then OG is not present, so it is false. Okay, so let's take a look at how we will solve this problem initially. So how intuitively we can solve it. If you look at LeetCode, what you will do is you'll basically check if L is part of the dictionary, no. If LE is part of the dictionary, no. It's LEE is part of dictionary, no. But is LEET is part of dictionary? Yes, of course it is true. And then you see if lead C is part of dictionary, no, it's not. So if then you will see is lead co is part of dictionary now, but then lead cod is a part of dictionary now, but if lead code is part of dictionary, yes. So basically if lead is already been processed, then you have to just process from cod and check whether this particular word is in the dictionary. How can we formulate that? This is going to be a solution approach. So basically we're going to use DPO, right? So this is a dynamic programming approach for a problem, because once you know that lead is already present in the word dictionary, then you can just go ahead and worry about the next string. Okay, so the basically the current the next state is going to depend upon the previous state calculations. So what you can do is dp, if at all, if you have dpo of 0, because null string this is going to be true, right? So what you will do is, if in the case of, let's have length is equal to 1. Okay, length is equal to 1, and let's iterate from the 0th index until the length. So we will just get L. So actually L is not present in the dictionary, right? So dp of 1 is going to be false. Okay, and then let's take length equal to 2. So if you consider length is equal to 2, dp of 1 is already false. So if you consider the next, it is also not going to be present, right? Of length to LE is not going to be present, so dp of 2 is actually false. Okay, now if you consider length is equal to 3, then if you see dp of 2 is false, so this is also going to be false. Okay, now if you consider length is equal to 4, so in this case dp of 4 is true because this is actually present. Yeah, this is going to be present. Okay, so basically what I'm trying to say is that when you consider a particular length, right, if the previous state has already been processed, you can reuse those intermediate solutions to come arrive at the current state's possibility. Okay, so what are we doing is basically we are fixing the length, right? And then we are saying whether we have seen dp of 0 earlier, and we are processing the next. So basically if a string is given like this, s1, so cat 1, cat 2, cat 3, basically what we are doing is we're segregating the problem into two pieces, and if dp of this c1 has already been processed, then we are just looking into c2 and c3. We're just processing c2 and c3, and then we are taking the combination of this process, right, and taking a combination of this total length, which is of 3. I hope it is making sense. So let's code, and I'll walk through the program if necessary at the end to be more clear. So for just making use of contains, I'm just going to have this word dict in the list as part of a hash set. They are saying that the dictionary doesn't contain duplicate words, but let's use a hash set just for simplicity's sake. So I'm going to use a hash set. This is going to be a new hash set, and what I'm going to do is I'm just going to have this word dict. So now we do have everything unique. So we are supposed to return a boolean. Okay, so we are going to have a boolean dp array. So of so this boolean, it's going to be ssr string and then +1. So what you can do is you can do some null checks. So what I'm going to do is if s is equal to null, or s dot length, if this is equal to 0, then actually you cannot have any word segmented, right? So this is going to false. And similarly, if word dict, if this is equal to null, or word dict dot length, okay, not actually, this is a list, so you have to consider size. If this is equal to 0, then you're going to return false. Okay, and then let's come here. So what we'll do is dp of 0. This is just null string, so we're just going to have it as empty. Can be obviously split it into, and now null string is part of any word. Okay. And then let's start. Let's fix the length. So length is going to be 1. Okay, and length is less than or equal to s dot length, and length plus plus. So now inner loop is going to start from int start index is equal to 0, and we will iterate only until start index plus plus. Okay, now if we have previously processed dp of start index, right, if this is already been processed, if dp of start index has already been processed, then we should just consider whether this verdict, if this is contains what it is going to contain, we're just going to check whether s dot substring of start index, okay, comma length. Okay, we're just going to consider whether this particular thing, if dp of start index is there, then we'll check whether substring from start index to the current length, if that string is already is there in this dictionary. Okay, if this contains this, right, then what you can do is you can just say dp of this particular length is true, because start index is there, and then the next the prefix is also there, and then the rest of the string is also there, which means the total string is going to be there. So in the case of LeetCode, leet is the prefix, this is there, and code is there, right? Code is there in the dictionary, so which means LeetCode itself is present in the dictionary. In this case, once you figure out this, then you should actually break out of it, so that you need not go ahead and process and overwrite this. Okay, and then finally what we are going to return, looks like there are so many so this will break, and this is this more, this inner for, and this is outer for. So what we are going to return is we are going to return dp of s dot length, which is whether we are checking whether the current string is completely present there or not. Okay, so let's take a look into this example. So let's say s is equal to leet. So for simplicity, I'm just taking leet. Okay, and let's see if this is present in dictionary. Let's consider the same dictionary, so leet, and then let's consider code. Okay, so initially what you will do is you'll set dp of 0 is equal to 0. Okay, now len is equal to 1, and so where is it? I don't know why control went there. So len is equal to 1. So our start index will start from 0, and then it will less than 1, so which means you can iterate on the ones. So we see dp of start index is is true. Yes, of course it is true. And we check whether the word dict is having this particular word. So leet, right, leet dot substring of start index, which is 0, so 0 comma 1, right? If this is present, no, L is not present. It is actually 0 comma 0 is empty string, which is not present. So this means that dp of the length will still remain as false. So dp of 1 is going to remain as false, right? So if you consider len is equal to 2, okay, in this case start index will begin from 0, and then it will iterate until 2, which means you can iterate for 0 and then you can iterate for 1. So dp of start index is of course true, but then word-dict of 0 comma 1 is not present, right? So dp of 2 is going to be remain false. But even if you consider 1, right, dp of 1 is already false, so dp of 2 is going to be false. So now if you consider len is equal to 3, which means iterate from start index is equal to 0 until it is less than 3. So if you consider dp of start index is true, but then word-dict of 0 to 2, so le is not present in the dictionary, so that is going to be false. Okay, so dp of 3 is also going to remain false. And even if you consider start index from 1 to 3, right, even in that case 1 and 2, so lee is not present in the dictionary. And if you consider 2 to 3, then that is also not present in the dictionary, so lp of 3 is going to remain false. Now let's consider len is equal to 4. Okay, now start index can actually range from 0 to 4, and dp of 0 is true, and then we have to see whether word-dict of so we have to basically see start index of dp is 0, so word-dict of 0 comma 3, I mean 0 comma 4, length is 4, so 0 to 3 is 0 1 to 3. So leet is actually present in the dictionary, so which means dp of 4 is actually true. So once you figure out that this is the answer, you actually break out of it. So so by this time output loop will also come out, because we have reached the end of the string, and so we'll come out and return dp of s dot length, which is dp of 4, which is true. So of course leet is present in dictionary. Hope it was clear. And if you consider the time complexity, it is going to be of n squared, because basically rise rating and 2 loops, and this goes from s dot length, and this is going from s length, so at the max it's going to be of n squared. Okay, so and this is basically, this hash set is basically for considering easy manipulation of this. So this is not required, this is not going to consume more space. Okay, so let's quickly run this code. It's accepted. Let's submit this code. Yeah, and it's a successful submission. So that's it, guys. I hope you understood this. Please like this video. Bye.